Okay, so you might be used to this sort of pattern now. You can see on the bottom we've got 25 minus x squared, yeah? And you might see that we have similar situation as the last time, but this time we've got an x squared on the top, right? So we have to be challenged in a different way this time around. So if x is 5 sine theta, x squared then will of course be 5 sine theta all squared. Okay, so in other words, x squared is equal to, we'll square it, 25 sine squared theta. Okay, and just like before, we need to work out what dx is. So let's differentiate. So dx by d theta is equal to 5 cos theta, of course, which implies then that dx is equal to 5 cos theta d theta. Okay, just take the d theta up. Let's sort the limits out when x is 0. Okay, in here, in our main substitution, 0 will equal to 5 sine theta. So that means, of course, then 5 times sine theta is 0. So that means sine theta's got to be 0. Okay, which implies then that sine to the minus 1, if you take that sine over, sine to the minus 1 of 0 will be left then with theta, which of course then comes out to 0. And when x is the upper limit, this time is 5 over 2. So 5 over 2 is equal to 5 sine theta. Going back to this again, yeah? Okay, and what's nice there is that the 5's cancel. So you've got 1/2 equals to sine theta, which implies then sine to the minus 1 over half is equal to theta. Check it out on your calculator and you get pi by 6. Okay, so our integral becomes lower limit is 0, upper limit is pi by 6. So then let's see what we've got. Well, in this fraction, x squared on top, yeah? And we know x squared is that, 25 sine squared theta. On the bottom then, you've got the square root of 25 minus x squared, which of course is this. Okay, so there's our root. And then you've got to times it by then dx, which is 5 cos theta. Okay, d theta. Okay, so the top there, we can't really do anything with that at the minute. I'd leave it like that, and you're timesing it by 5 cos theta as well. Okay, nothing much you can do. But at the bottom, you might recognize similar pattern to before. Okay, notice there we've got a common factor of 25. So in the root, factorize out the 25. And lo and behold, you get in that bracket 1 minus sine squared. So don't forget to put all the other stuff there. But 1 minus sine squared quite simply becomes cos squared. So on the bottom, you've got the square root of 25 cos squared theta. Okay, for the 1 minus sine squared. That's the equivalent. That's what 1 minus sine squared is equal to, is cos squared. And then on the bottom then, lovely, you can see you're rooting 25 cos squared theta. So if you root 25, you get 5. If you root cos squared, you get cos. And then, of course, what's nice is, look, you've got 5 cos theta here and 5 cos theta there. They cancel. So you're just left with the integral between 0 and pi by 6 of 25 sine squared theta, d theta. Okay? Or you could write that as 25, the integral between 0 and pi by 6. So take the 25 out of sine squared theta, d theta. And we're left to integrate sine squared. Okay, so this goes back to the video at the start, okay, where you've got to integrate sine squared. And quite straightforward, isn't it, once you get used to it. Okay, so remember the double angle formula, okay, so quite simply here, we're going to use the one involving sine squared, yeah? So it's that one there. So it's just a case of rearranging this then, okay, so that means then from there 2 sine squared theta is 1 minus cos 2 theta, and then sine squared theta will equal to 1/2 of that, yeah? Okay, because you're just taking the 2 over, dividing then both terms by 2, so you can just take it out as a factor of 1/2. That's what sine squared is. So going back to our integral, okay, between 0 and pi by 6, let me not forget the 25 there, okay, times then replacing the sine squared theta by this, okay. So what we can do then is, well, our half actually we could take outside as well, couldn't we? So 25 over 2. And then let's integrate this. So 1 becomes theta, and cos 2 theta becomes sine 2 theta over 2, okay? Or minus in this case here, because there's a minus there. Sine 2 theta over 2, and then there's our limits. Okay, so we're going to put in 25 over 2. So the upper limit is pi by 6, take away sine 2 pi by 6 over 2. Take away then the lower limit, 25 over 2, well, it's going to be 0. Take away sine of 0 over 2. So that's all going to go, so it's going to vanish. And if you do that on your calculator, we did this before, it should come out to be 1.1323, hopefully. Okay, if you type that in there, and we're done.